right, so we're going to go ahead and revisit transformations, but now we're going to do it for the function, the parent function 1 over x. And you can see that I have the parent function actually graphed right here. This is what the parent function looks like. In fact, right here on the y-axis and the x-axis, they are vertical and horizontal asymptotes. You can't really see it too well because I have them overlaid right now, but this is an asymptote and this is an asymptote of 1 over x. The key to the way that we do transformations is we need to know what function, what points we're going to use to transform. So I'm going to show you the ones that I use. So I'm going to do x and y, and I want to make my table. So I'm going to think I need something on this side over here and then something on this side over here. All right, so I'm going to do -2, -1, -1/2. I'm going to do 0, and I'm going to put like a little star right here because that's actually going to tell me where my asymptotes intersect. So if I can actually just move these asymptotes around, I can kind of have the general idea of what's going on with the graph. Then I'm just going to mirror this 1/2, 1, and 2. To get my y values, I plug them in here. So I'm going to get a -1/2, a -1, a -2. This is undefined, but it's technically 0 because we're looking at this 0.00. We're not looking at it as terms of the function. We're looking at where the asymptotes intersect. That's why I have that little star right here, because this is not actually on the graph, but that's going to help us graph this. Then I'm going to do 2, 1, and 1/2. All right. So those are the points we're going to do for our parent function. So now I'm going to say, hey, you know what? Here's g of x. And I want you to graph 2f of x minus 4 plus 3. Well, we know that this would actually be 2 over x minus 4 plus 3 because of our general form af of b times x minus c plus d. That's where we're getting this from right here. So my f is the 1 over x, but this x part now goes to the bottom. We put it in the x minus 4. The 2 goes on top, and my 3 goes in the back on the back end. All right, so we're going to do my table, and I'm just going to add it on over here so we can do our mapping. And we're going to look and say, all right, well, my x's, it's everything that's on the inside that affects the x's, but it's opposite. So this is x minus 4, so we're going to do x plus 4. So when I put this in here, -2 plus 4 gives me 2. -1 plus 4 gives me 3. This gives me a, what, -3.5. My 0 turns into a 4. This gives me 4.5. This gives me 5. And then this gives me 6. Over here, my y mapping is everything on the outside. So we're doing 2 times, this whole thing is a y, 2 times y plus 3. So 2y plus 3. So this gives me a -1 plus 3 gives me a 2. -2 plus 3 gives me a 1. -4 plus 3 gives me a -1. 0 plus 3, this gives me a 3. And then 2, 4, this gives me a 7. 1 plus 3 gives me a 5. And this gives me a 4. And then from here, we just plot our points. But I'm going to show you a trick to give me a general idea of what's actually going on. I'm just going to plot this point right here, 4, 3. And I'm going to draw in the asymptotes. So 0, 1, 2, 3, 4. So here is so there is my vertical asymptote. Y equals 3. So let's see. 0, 1, 2, 3. Here is my horizontal asymptote. Then to graph it, I'm just looking at, is there a reflection? Because it could reflect this way and this way. So we can reflect over the x. There's not. So my general shape is still going to look like this. You don't really have to plot these points. I'm not going to be super picky and make you plot the points, but I will look to see to make sure you do the table. But really, if you can get your asymptotes in the right spot, these bends either is going to bend closer here or further out, and that's what this will tell you. But I'm not going to be super picky about this if you can just do the general idea of the transformation. So let's see how accurate I am. So let's go ahead and change this equation right here to this equation right here to see how close I am. All right, so my A is 2. My C is going to be 4. 4, and then my D is 3. And how accurate am I? Not terribly bad, really, for drawing on a blank piece of glass in front of me. Not horribly bad, but you can kind of see this gives you a general idea of what the graph is actually doing. You can be more precise by plotting all of these points. I'm really indifferent. Now, you know from transformations that we can do the written description. I can give you the equation, ask for the written description of the graph, and ask for a written description. We've been doing this for quite a bit now. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.